And we're back. Here we are on yet another episode of From the Workshop. Once again, I am so honored to be your host for this episode of From the Workshop. Here in the NimbleLink Nerd Lair. Also, once again, where else would we be? This is From the Workshop after all. And to help us along our M1 journey is once again NimbleLink head engineer Kurt Larson.
Hello.
Got to put that on your business cards.
Head engineered.
Yeah.
Work on that.
So as you may have seen in our previous episodes, we've really kind of been diving into M1 and what makes it cool and what it is and how it works and what are the features of it and all that kind of fun stuff. But all of that is sort of conceptual and theoretical. What happens when you really want to, roll up your sleeves and get your hands dirty and dig in and start using it? Where do you start? What do you do? How do you can you touch M1? Can you grab hold of it and experience all its glories? How do you do that kind of stuff? So that's what we want to talk about. So kind of to take it maybe from the ground up or the smallest component up, we'll start in by talking about the hardware and the radios themselves, and then kind of build your way out from there into the device and the service and where you're sending the data and all that kind of thing. Sound like a plan?
Sure.
Let's do it. So obviously, NimbleLink, we make cellular modems. We've been talking about our M1 Skywire modem. That's going to be a pretty clear recommendation, I would say, from us as far as a good way to get started. But what are some alternatives? What are some other ways, just to be fair,
Sure.
that people could get started?
So there's basically four different levels of engagement people can consider, or OEMs can consider while looking at new cellular technologies. The first is at the chipset level. So these would be folks that actually make the LTE chipset technologies. Companies would be Qualcomm, Sequans, Altair, Intel, Infineon's group. Those are the people that make the chipsets. Those chipsets are typically sold in the tens to hundreds of millions of units into the highest volume applications in the marketplace. Most of them will not supply to anybody that's buying less than literally tens of millions of units. So the next tier that gets a little more approachable is the module level, so the cellular modules. This would be the likes of Telit, Sequans, WNC, U-Blocks, Gemalto. All these organizations buy the cellular chipsets and put them into cellular modules.
So that's what's under the metal shield there on a
Correct.
module.
Yep.
Okay.
So a module kind of starts the certification process. It's targeted for companies that are buying 20,000 units or higher, because the certifications that the end users have to go through on their products take more time, cost more money, etc. So the third level engagement, which is where NimbleLink plays, is in the cellular modem level. So we are a customer of Sequans and Gemalto and Telit and all those other module providers we discussed. We create the embedded modems, and we take those through the end device certification process with the cellular carriers, which allows our end customers to not have to go through any certifications.
Sure.
So that's level 3. And then the fourth level is folks or OEMs that make finished products. So that would actually embed all the cellular technology inside of some sort of encased product. And those would be another place where customers can engage with the technology. Today, we're really focused on the M1 technology and conversations. That's the latest technology available from the networks and the module and chipset suppliers. So NimbleLink has some of the M1 specific modules implemented in embedded modems. So that's the embedded Cat M1 modem that we have here.
I'm just giving you some visuals.
Perfect. They're just behind me.
Yeah. All right. So sort of like that. Excuse the handwriting. So I'll also point out that you can click right here on this diagram to be taken to the video where we talk about chip chipset, module, modem, and the relevant certifications for each one of those. So click right here. There you go. Good. So those are the different levels. So generally, you're not going to have a whole lot of dev kits and people just getting started here at the chip level, right?
Correct.
It's painful and
multiple year process to engage at the chip level.
Millions of devices, that kind of thing. Module level, much easier, and there are dev kits available for that level.
Correct.
But even then, you're talking about custom PCBs if you want to move past just using the actual provided dev kits.
Correct.
And then when you make a device, of course, you're going to have to go through certifications. Modem is what we're talking about here with Skywire. And if this level, certification's already done and device certification done. I put this one as kind of a dashed line on the outside here because certifications-wise, there isn't anything beyond this level, really. You could take a module and put it directly into your end device here if you wanted to, but once you've got a modem, you don't need to do any additional certifications. So this is sort of an extra level. If you're using a modem, you would put that into a device and have a full
finished
product. Yeah, maybe we should put that. Finished product.
Beautiful handwriting.
Thank you. Yes.
I love your font.
Getting awfully personal there. So basically, what we wanted to kind of talk about then is, assuming you have all these options, assuming you make the decision to go with a modem, because when we talk about M1, that's really going to be the easiest kind of jumping off point to get started.
Correct.
Again, maybe a little biased on that, but I also firmly believe that to be the case. So how would you then go from getting one of these modems and actually getting it to do something, read sensors, connect to the network, and so on?
Sure. So the modem as an embedded device requires some sort of carrier board to allow you to interface to it easily. And so as a NimbleLink, as a company, we've tried to break down both the hardware integration barriers as well as the software integration barriers, as well as the carrier connectivity barriers around cellular in general. So with the Cat M1 modem specifically, we have created a family of development kits to support different processors and different operating systems, depending on what type of system you as the end user or you as the developer want to take and use to work with the Cat M1 technology. The first one that Brandon picked up here is actually what we call our Cat M1 development kit. The model number is an M1 DK. So these are specific adapter boards that allow you to take the embedded modem, plug it into the adapter board, and you have a lot of different options of how you then use this to do your development. So first of all, it has direct USB connections on it that allow you to attach it to a traditional computer. So if you have a Windows PC, if you have a Linux PC, or you have a Mac, you can interface using a USB cable from this board directly to your computer and start communicating with the module with AT commands.
But Kurt, we have talked about dev kits before.
Sure.
From the workshop, and we kind of showed the Skywire development kit, the SWDK,
Mm-hmm.
and really recommended this as the best place to start for all of our Skywire modems. Now that M1 comes along, you're pointing at this one, saying that this is the one they should get started with. What gives?
What gives? Good question. So if you already have an NL SWDK, which is this development kit here, the M1 modem can be used in it. The reason we created this kit, actually there's a handful of reasons. One is early in the development of this, in early 2016, when we started to engage with Sequans, the technology supplier, they were going to need specific features brought out in order to certify the LTE chipset and certify the module within, and also facilitate the certifications of the NimbleLink Cat M1 modem. And so this development kit, not only does it provide the connectivity that a user or a developer needs to access the modem, it actually has some additional debug features that are specifically tuned for the Cat M1 cellular technology.
Hmm.
Okay, so as an end user, you're not going to have to worry about those things. You know, we don't expose any of that to the end user. There's no reason to gain access to that. The second reason that the M1DK is important is in the Cat M1 modem roadmap, there are versions of the modem that bring out a GPS chipset on the modem module itself. And so this is an added feature that never existed on some of the previous modem LTE technologies. And so the NL-SWDK does not have the required signals to be able to gain access to that GPS interface. And so on the M1DK, we have access to an additional UART, which allows you to access the underlying GPS technology that will be coming slightly after the initial launch of the versions of the modems that don't include GPS. Okay. So that's coming.
So this one should really only ever be used for the Cat 1 Skywire modem. Won't work for any of the other ones.
That's correct. This would be specific for the M1, Cat M1 modems, not any other Skywire product lines.
Okay. So they'd still use this one if they were doing anything except for M1.
Yep. The other thing that we did with the M1DK to help hold true to the promise of low power, the NL-SWDK, the older development kit, it had features that made the modem work in like all environments across all temperature ranges, but it wasn't necessarily designed for low power at its onset when it was designed over 5 years ago. So the M1DK, in order to ensure the low power promise and allow customers to be able to quickly develop and demonstrate the low power nature of both the M1 modem and the systems that can support an M1 design, there are specific enhancements to this development kit to enable the low power and really take advantage of everything that the M1 promises.
Okay.
Specific to that is on the bottom side of this, there is an Arduino compatible interface, not necessarily to work with Arduinos, but to work with all the other development kits that share that same common footprint, like the Freedom 64 platform from NXP, the ST Nucleo platforms from ST Micro. These products are very appropriate for doing extremely low power designs. And so, for example, we have a ST Nucleo here connected with an M1DK and a modem, and using those three pieces together, we can create extremely low power systems and reference code for companies that want to create low power designs. The Arduino family of products, unfortunately, the processors are not really what we would consider low power, and the IDE environments for development don't necessarily take advantage of the full power, low power nature that some microcontrollers can have. And so even though we call it an Arduino interface, it's really intended for some other microcontroller development platforms that are more suited for being married to an M1 platform.
What's that little white thing right there?
The white thing is so you can actually plug in a lithium-ion battery.
What?
So there's, if you want to create a full-up system, we've tried to make this so you can plug in a battery, you can plug in your target processing board, and then we also have design files on the website for enclosures that you can 3D print at your favorite 3D printing house and modify those files if you want to make adjustments to it. With the intent of being able to enable people to create their sensor development platforms and start deploying them in the field for field trials.
Cool. That is awesome. So this doesn't even need to be plugged in with one of these wall warts. You could actually plug it in with a battery.
Correct.
And chuck it somewhere.
Yes.
Have it start sending sensor data.
Yep.
Fantastic.
Yep. Single cell lithium-ion polymer battery is what it was designed for. So it's
cool.
I believe there's even the charging system on it for that lithium-ion battery. So if you do want to provide supplemental power through solar or USB connection or something, you can charge the batteries as well.
Okay. Another silly question for you on this one here. We keep extolling the virtues of M1 being a single antenna solution, half duplex, and not having to worry about designing in antennas that have to have a certain amount of separation and all that kind of thing. But there are two antenna connectors on here, so that doesn't make any sense. What's going on with that?
Yep, so that goes back to the earlier statement about the product roadmap and having GPS-capable modems. So the Cat M1 Skywire modems There are versions that you can purchase that have GPS chipsets within, and that second antenna is specifically for the GPS RF path.
Got it. Does it matter which one I use for what?
Technically, no, but it would be mechanically difficult to swap them.
Get them around. Okay, cool, awesome. All right, so enough of that. So M1 DK, if they want to get started actually talking to the thing, it can just operate like this if you put a Skywire modem into it and plug it into your computer.
Correct.
Otherwise, you can tap into a dev board of your choice and start writing code on that to then utilize the Skywire modem.
Yep. I think it's important to point out that also the design files for those adapter boards, so the schematics and the layout files, the bill of materials, as well as all the same files for these development platforms are all open source. So a developer can literally buy the modem, copy the schematics from any of these development platforms to create, a unified,
compress it into one custom PCB,
so that not only can you develop and prototype and create field trials with the 3-board stack, when you actually want to go to production, you have all the resources hopefully to be able to compress that and reduce your BOM cost and take that to production.
Awesome. Seems like a really quick way to get a device developed and deployed.
That's the intention.
All right.
Do we want to cover
That's a great strategy.
The BeagleBone and some of the other devices as well? Or
yeah.
That
so that's
video?
Yeah. So I mean, we're kind of focused on M1 here. We talked about the microcontroller boards and kind of how to keep things lower power. But when you want a little more horsepower, does it still make sense to use M1 for a higher power, full operating system Linux single board computer platform?
That's a good question. The decision really resides around two things. One is price point,
okay,
and one is how much data you need to send to the internet. So the BeagleBone and Raspberry Pi and other Linux equivalents like the products from Intel and others, by nature they are very high power systems. So they run a Linux operating system or a Windows embedded environment. They're going to consume amps and amps of current just to keep the operating system alive. So the modem's power is typically dwarfed by the processing power required just to run the development kit.
So the fact that it's low power in that
don't
case
get the benefit.
Doesn't really matter.
Now, extreme circumstances, long life solar power with a battery pack of some sort, you can still do low power with these systems. It's just a much more a higher power starting point from a processing perspective.
Right.
So back to the decision criteria. One is price and one is bandwidth.
Yeah.
So if your application is really low bandwidth, you can get away with using a Cat M1 modem.
Okay.
But if you're trying to send videos or compressed images or files across the network, that a Cat 1 modem or a Cat 3 LTE technology would be better suited from a bandwidth and speed perspective.
Sure, but those will cost you more.
But they'll cost you more. And so that was my second statement about price. The M1 modems are priced physically lower because there's less materials in the BOM stack up for a M1 device than you would see in a Cat 1 or a Cat 3 class LTE.
Okay, cool. So it still can make sense in some instances.
Yes.
You get the best benefit of M1 at the lower power microcontroller design idea, but even using a full Linux OS and a single board computer can still make sense.
Yep.
For the right opportunity.
As long as the bandwidth is low.
Okay. So dev kits, hardware aside, where do you go from here? Obviously, it needs to be able to connect to the network in some way. So you'll have your antennas that you got to connect to the hardware, but then from there you got to get it actually talking to and over the network, right?
Yep. So there's a three-legged stool. You need a device, you need a network, and you need a SIM card. So the device is the modem itself. The SIM card you can get from Verizon or your favorite carrier for the network you're trying to deploy on. NimbleLink makes the SIM cards available through our website. And then the network side, Verizon and AT&T are rolling out their Cat M1 networks as we speak.
Okay.
And more and more locations are becoming available every day. In order to activate a data plan, if you're not already set up as a customer with one of those organizations, you can actually go to go.nimblelink.com
It's up here now?
It's up here now.
Okay.
Go.nimblelink.com. You can activate your SIM card and data plan within a few minutes.
Okay.
So for customers that are doing development, it's a great way just to get something going immediately.
Yeah.
While you work out your formal business arrangements with the carrier for long-term planning.
And the SIM card you need for an M1 device is just a run-of-the-mill SIM card.
No, it is not. The M1 SIM cards, at least on the Verizon network side, are a different part number. And so the three-legged stool involves a new unique SIM card, which we include in the M1 DK development kit.
Right.
And we also sell that SIM card part number through our distributors.
Okay. All right. So it is a specific, I just want to clarify this, it is a specific SIM card for the Verizon M1 network.
Correct.
Not the same LTE SIM card that works in all of our other Verizon LTE modems.
That is correct.
Okay. All right. So that's clear. Cool. So that's the hardware discussion. Kind of gives us an idea where to go from.
One more thing I wanted to share that was about design trade-offs. In the sense of, if a customer or somebody just wants to explore with M1 and you ask yourself, well, where should I start? There's 5 development kits here in front of me. Which one should I start with? The lower power development kits require a steeper learning curve to get operational and working in your environment. The higher level operating systems that are supported on Raspberry Pis and the BeagleBone products, etc., are much quicker to get connected quickly.
Is that because they have their own network stacks and there's a bunch of examples and things like that out there that you can just sort of use, open source libraries and things you can just use?
Because you're taking advantage of the Linux operating system that's been around forever, you're right. There's lots of networking stacks and we provide examples on both environments, but you're going to get a lot more flexibility and speed out of something that's already running Linux if you're just trying to test it out and play with it.
As opposed to trying to use the proprietary network stacks and AT commands to access those network stacks that exist within the modems.
When you get into the Linux, you can use things like ping and FTP transfers and things that people in the computing world are common knowledge. When you get into the more embedded designs, implementing a ping is much more difficult, and FTP is not really a concept because these don't use files per se.
Right.
So if you're just trying to test out CAT-M and want to see what it can do, and you want to see what the latency is, you want to see what the throughput is in an actual device, I would steer you more towards a Linux or Windows-based experience.
Cool. All right. Very good. Well, thank you for taking us through that. So basically, from that point on, you have your special M1 SIM card, you've got your devices, you've got your M1 Skywire modem. The rest of it is pretty standard fare. Getting connected to the network, you need a line of service, you need some place to send the data to that it will show up and be visualized on the internet. But as far as getting started with M1 and what's unique about M1, that's really helpful. So M1 DK, M1 Skywire modem, M1 SIM card, and dev kit of your choice.
Correct.
Awesome. Well, thank you very much again, Kurt. We appreciate you coming on to the show, talking us through all of this, allowing us to be here in the NimbleLink Nerd Lair. And for those of you out there in From the Workshop viewer land, we hope you'll join us for the next From the Workshop. And leave your comments. Any questions you have, put them in the comments down below, or you can hit us up at the From the Workshop email address here, which is workshop@nimblelink.com. And with that, we'll see you in the next From the Workshop video. Thanks a lot. Have fun developing.